In this video, we're going to look at the equation x squared minus y equals 1. And this equation has some nice simple solutions. For example, if I were to set x to 1, then x squared is 1. And then if I were to set y to 0, then x squared minus y is 1. So x is 1 and y is 0 is a solution. In exactly the same way, if I set x to minus 1 and y to 0 is a solution. And if I set x to 0 and y to minus 1 is a solution. And what we're interested in here is the slope at these special solutions. So by slope, what we're interested in is what small change in y is due to a small change in x. And we're going to call the small change in y dy, and we'll call the small change in x dx. And the slope is actually the ratio of these two small changes. The slope is dy over dx, the small change in y caused by the small change in x. And we're now going to apply this idea to these special solutions. We'll first look at the solution 1, 0. So in 1, 0, the initial value for x is 1. And remember, we're doing x squared. So the initial value is 1. The small change in x value is dx. Since it's x squared, we squared this new x value. And the initial y value was 0. The only change to it is dy. So minus y is now minus dy, since the initial y value was 0. And this whole thing is equal to 1. If we expand the expression on the left, we know that 1 plus dx squared is roughly 1 plus 2 dx minus dy equals 1. And if we now, we can now cancel the 1's on both sides, and we can see then that dy is equal to 2 dx. And since we're interested in the slope, at 1, 0, dy dx equals 2. So that's the solution at the first point. We can now go on to the second point. We're going to look at the point minus 1, 0. So here, again, we're interested in x squared, but the initial value for x is now minus 1. And then the change is still dx, so minus 1 plus dx squared. Y's initial value was 0, so the new value for y will just be minus dy equals 1. And if we now expand the term on the left, only keeping the dx term, because the dx squared term will be too small, we'll get 1 plus, oops, not plus, minus 2 dx minus dy equals 1. We can cancel the 1's on both sides, and then we see that dy is equal to minus 2 dx. And so we see at the point minus 1, 0, that dy dx is minus 2. And finally, we can consider the final point. The final point, 0 minus 1. And here we see that the initial value for x is 0. So the new value is just dx. Since it's x squared in the equation, it's dx squared. The new value for y is negative 1 plus its change dy is dy equals to 1. And so we get dx squared plus 1 minus dy equals 1. The 1's on both sides cancel. And we get that dy is equal to dx squared. So let's consider a small change in x. Let's say that if dx was 1 part in 1,000, the change in y is dx squared. So that's 1 over 1,000 times 1 over 1,000. dy would be 1 part in 1,000,000, because 1,000 times 1,000 is 1,000,000. And so we see that if there's a small change in x, the change in y is much, much smaller. The change in y in this case is 1,000 times smaller. And 1,000 times smaller means essentially it can just be ignored. And so at the point 0 minus 1, we see that there's basically no change in y for small changes in x. And we therefore get that dy dx is 0. And so at the 3 points 1, 0, we get the slope of 2. At the point minus 1, 0, we get the slope of minus 2. And at the point 0 minus 1, we get the slope of 0. I hope this video was helpful, and I'll talk to you soon.